Hello everyone. In this video, we're going to be solving a functional equation. We have f of square root of x minus 1 equals x plus 2 times the square root of x minus 1, which is the same expression that we have inside the parentheses. So does that mean anything? We'll talk about it. So we're going to be solving for f, which means we'll try to find an expression for f of x in terms of x. Okay? Let's see how we can do that. And I'll be presenting two methods. Let me know which method you like better. And if you like complex numbers, I have another channel. Go ahead and check it out. It's called aplusbi, just like a complex number. Now, for my first method, I want to do what is typical. Normally, when we're given an f of something and we want to find f of x from there, basically we want this to turn magically into x, but we can't do it directly because then we would be solving for an equation. We don't want a numerical value. We kind of want some type of transformation. In other words, we need the inverse so that f composition f inverse will give us the identity. In other words, we can set this equal to a variable. How about u? Okay. If you set it equal to u with the radical, of course, we get something like this. The square root of x minus 1 equals u. And then from here, our goal is going to be to solve for x and then substitute that on both sides of this equation. Great, let's do it. Now, to solve for x, we should square both sides, don't you think? If you square both sides, you get x minus 1 equals u squared. We're so close. You know what we need to do? Add 1 to both sides, exactly. So x can be written as u squared plus 1 or 1 plus u squared, whichever you like better. Now, this is something that I can use everywhere because now I was able to express x in terms of u, which comes from the fact that I set this whole thing equal to u. Don't forget that. Okay? And then we're going to go ahead and substitute that here and here. Okay? Cool. Now let's go ahead and do that. Now what happens if I replace the x with u squared inside the radical? Well, here's what you get. You get u squared plus 1 minus 1, and then the ones cancel out, leaving us with the square root of u squared. Provided that u is positive, this becomes f of u. Wait a minute, how do you know that u is positive? Well, we do know that because remember, the square root of something equals u. If these are real numbers, then u has to be greater than or equal to 0. Can u be 0? Well, yes, because if x is 1, then u is 0. Right? That's why we kind of need to set it equal to greater than or equal to 0, not just greater than 0. Okay? But if x is equal to 1, then you kind of get f of 0 equals 1, which is something we can also use to check our function at the end. Okay, so we did get f of u on the left-hand side, and on the right-hand side, what are we getting? Well, first of all, from here, we get u squared plus 1. And then here, you know that it's going to turn into a u, so we get that. Done. Case closed, right? But take a look at it. We don't want u to be the variable, independent variable at the end. We want it to be x. So now, regardless of the previous x we used, and totally forget about it because sometimes people just get stuck. Oh, come on, you said x is something else. That's gone. Wipe it out. We have a new x, okay? So we're going to replace u with x everywhere, and that's going to give us f of x equals x squared plus 1 plus 2x. Now, you can leave it at that, but I wouldn't because this can be written as x squared plus 2x plus 1. And that's actually a special expression. Do you know why? Because this is a perfect square, and that's just perfect. We can now write it as f of x equals x plus 1 quantity squared. So this is probably a more simple, a way to express it, right? Maybe a nicer way to do it. More compact, at least, right? Takes up less space, which is a good thing. Okay, so that is f of x. And let's go ahead and do our check real quick. We don't have to do it for the second method, but let's do it with the first one. Remember what I told you? If you replace x with 1, you get f of 0 equals 1 plus 0, which is 1. So f of 0 is supposed to be 1. Is it correct? F of 0 is 0 plus 1 squared. That's actually 1 squared, which is 1. Yay, it checks. Obviously, this is by no means a proof, but at least we were able to check. And you can use multiple values if you want, if you doubt your solution. But if I were you, I wouldn't. Great. Let's go ahead and take a look at another method, which I really like. That's actually how this problem came about. Like the idea for this problem comes from the very fact that I was able to come up with some sneaky, I would call this sneaky because when I show you what I'm talking about, you'll agree with me on that one. Okay, great. Now, you probably noticed when you first saw this problem, we have the square root of x minus 1 in two places. Great, but the one that's outside has a 2 in front of it. What is that supposed to mean? Not much for now, but this is something we can hopefully take advantage of. So here's what we're going to do. A little bit of hocus pocus allow me to do a little math magic because that just does miracles. So here's what we're going to do. I'm going to take the x and turn it into x minus 1 plus 1. Does that make sense? Well, minus 1 plus 1 is 0, so I'm actually adding, in essence, I'm adding a 0. Now you might be questioning, like, why are you adding 0? Because adding 0 is fun, first of all. Second, it's going to help us solve this problem really quick. You'll see now, okay? Watch it out. Now, this is f of square root of x minus 1 equals this. Now, I'm going to go ahead and take this positive 1 and put it at the end. Okay, does that make sense? Again, this is where the problem idea came from. I started with the solution, of course. That's always what you do. So this is x minus 1. This is 2 times the square root of x minus 1, and then plus 1 at the end. So here's the magic touch, the hocus pocus part of it. Of course, when I explain it, I want to explain everything in detail so that you're not, like, we're not skipping any steps, and so everybody understands what's going on, because not everybody is the same level in math, and that's perfectly fine. Some people are so impatient, like, oh, I can do this in 20 seconds. Great, then just do the problem in 20 seconds. But some people need 5 minutes, 10 minutes, hours, days, and that's perfectly fine. Okay, it doesn't mean you're superior. It just means you have a better math background. Anyways, so x minus 1 and square root of x minus 1. Do you see the relationship? I can write this as square root of x minus 1 squared. Awesome. And that kind of matches up with the term in the middle. Now take a look at this. If this is a, this becomes like a squared plus 2a plus 1. In other words, the right-hand side is a perfect square, and that's just perfect because it matches up with what's inside the parentheses. Now remember, you can do this directly, okay? You don't have to go to u or t or any other variable. Suppose we replace this expression with x. I'm not saying set it equal to, replace it with x everywhere, and you're going to realize, okay, we're getting the exact same solution, which is really, really cool, don't you think? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out aplusbi, and bye-bye.